2 years ago, I published on YouTube a description of my magnetically coupled rotor system. And when I published it, I was getting like 20 or 30 hits a day. And just one day I woke up about 2 years ago and I started getting thousands of hits, and it eventually went viral with, as you can see, 323,000 views, and it was really incredible. And I had 5,000 people subscribed to my channel, and I was producing videos, and I attracted some new funding, and had thousands of comments, and the comments, got really hyperbolic about, like, that I would be famous, rich, and of course, none of that came to fruition, but I did receive some more angel funding, and people were like, comparing me to different, famous inventors and physicists in the past. And here's something really kind of interesting that appeared. This is a image of, I think it could be fake, but Nikola Tesla did this type of flying saucer idea that was phantasmagorical, and I kind of was like curious about it and couldn't find much more information about it, but that's just an aside. So my patent initially showed this drawing of magnet arrays, and as you can see, there's a large magnet array in the middle, which is corresponding to this that I made, and smaller ones around it in a different sort of architecture. I had to look around the world to be able to find, somebody to make this magnet shape. And this is what's known as a planar-concave shape. And as you can see, I had the magnets axial polarized through the magnetic material, which is neodymium magnets in this case. So I had these magnets, and once I got them, I had to figure out a way to, put them together, and I knew they would alternate polarity to be able to rotate. And so with some machinists, we came up with this idea to put a bearing in the middle and then cut these little grooves so that the magnet shape would fit down into the aluminum that was milled. And so this was the concept, and this is, these are powerful magnets, and to hold them together in an array. So I made these arrays that were similar to my patent idea, and initially, and so we had a bigger ring magnet in the center, ring of magnets, and smaller arrays around it, 6 smaller arrays, and I went ahead and put armatures in the middle, and we spun it, and we were able to generate electricity. And if you notice, this was in the basement of Duke University, mechanical engineering. We put an oscilloscope on it, and the wave pattern became like this sawtooth. But the problem is that the initial armatures that I designed were just, didn't take into consideration some major things in electromagnetic motor system design and things. So they didn't work very well, but it really kind of illustrated like where I wanted to go with this idea. When I received more funding, I started to decide, okay, well, I wanted to build a system where I could hook up and show and prove to people that were watching on the internet that I could create current by transferring a central array of magnets and spinning them, and then have generators collecting the current that was through that was transferred through the kinetic energy without contact, just by the coupling. I went and I got like an engineer came down and flew down and started to do some testing. And as you can see, we set up voltmeters and a series of, to both read the volts coming in and the volts going out. And we set up some resistors. And what was interesting about this, which was a curiosity to him and other people, and is that the system was tended to speed up with constant voltage applied. And now why this occurred, we don't really know. There's a couple of reasons possibly for it, but I'm going to leave that aside and just say this was a curiosity. But it also, under load, it would do the same thing. You could add a resistor, the RPMs would drop coming from the central driving force, and but then it would recuperate. Anyway, I did that. What was also interesting, I started to play around with different architectures, and this is an example of where I placed these arrays in 3 arrays around a central array, and you can see how that worked. And I connected a motor to that, and as you can see, I was able to get RPMs of 5,600 and voltage of 19 volts out of each. These are connected to the generators that are up on top. And the voltage in, you can see, is about 14 volts in. And what's also curious is we're getting 19 volts out of each one of the 3 that are around the central one that's getting the 12 volts in. But that's also another curiosity that's occurring. But what I was interested in is we could spin with no contact rotation and kinetic energy really, really high RPMs. In one of my designs with this, I had this spinning up to 20,000 RPM. It gets dangerous at that speed because I worry about like the way of my, the holders for my rotor and the material, and it's like, it becomes like a projectile at those speeds. I also, with some of the angel funding, I developed this idea that you could put a 2 magnetically coupled system and have a pipe and have this become a pump or turbine system where water could run through it, and you could isolate the internal pump and from any mechanical thing, because it would be non-contact through a non-conductive medium. So I built that. Going back to like my core idea, which was, which really got to be curiosity, is that I made this shape of magnet, this planar concave shape, just sort of by accident. And it was really hard to get someone to make it at the time because it wasn't like common to be able to make, neodymium magnets. And so this shape is interesting because the planar concave shape is also used in optics, and magnetism and the magnetic field, flux field that emanates from the actual physical magnet itself is unseen. You can't see the field, you can't see light moving, but you can see its effects. So, so basically this planar concave shape utilized in a magnetic system instead of an optical system. And you can see in an optical system, a Plano-concave lens distorts the field and and changes the pattern of the rays of light that are moving through the lens itself. So I began to analyze kind of what was going on with my initial design, And I placed, like, here's kind of an example of what I did was I put a piece of paper with some metal shavings, and I got this pattern, and I got, kind of curious about like what was going on with the pattern. And then I found through the interwebs that there was this magnetic viewing film. And what you see happening is that at the edges of where the magnets, the planar-concave magnets intersect, the lighter areas are where there's greater field density. And this effect, is really kind of a curiosity, and it's the way my magnetic coupling system works, which differentiates it from conventional magnetically coupled systems. I got some better magnetic viewing film and laid it over the same array, and you can see really dramatically how the lighter areas, which are flux dense field lines projecting from these nodes where the magnets, and this is an interesting effect, this edge or field effect or fringe effect that occurs at the edge of magnets, because the polarization is going, like I said, the magnets themselves is going directly through it. And this kind of idea sort of represents like kind of what's going on. The magnetic flux lines are kind of going and connecting together at these points at the node, and you can see it's denser here, and and I'm drawing this, but it's actually a physical occurrence that occurs in nature too. And this is an atomic microscope image of a molecule, which is really like amazing that physicists and scientists can actually capture individual atoms interacting. And if you notice that this hexagonal shape of this molecule, and you notice that at these points, is kind of like they're a little bit lighter. And if you think back about the way my hexagonal arrays are, if you sort of separate these, then you could potentially think about them spinning if they have this kind of alternating polarity, which is kind of the way the bonding works. So like this effect is also occurs with linear molecular bonds, and this is sort of like a larger kind of idea. If you laid magnetic viewing field on this, you would get this. And if they were kind of slammed together so that they couldn't move, that becomes like one molecule. But when you separate them, they're actually spinning kind of in this nebulous space of but they do interact as the fields move down. And this occurs, it's scalable down to like a nanoparticle size. This effect could probably occur, but this is just a hypothetical, and theoretically, I'm just trying to understand kind of this new concept of a magnetically coupled system that allows transference of kinetic energy without any physical contact, like a mechanical gear. So this is like an example of, this is a capacitor field lines that are moving between each other, and you can see that the field lines are like in the middle are going perpendicular to the axis, and this is a positive and negative charge, and so you can say the flow. But also you start to notice that in this illustration, they always illustrate like sort of a density at these edges, and this has actually been studied, and you can see that this edge effect in capacitance, whereas this also works for magnetic fields as well as electric fields, is that the perpendicular motion through of this material, whatever this is, the capacitor material, magnetic material, at this edge is where the densest area occurs. And this is where my idea for coupling takes shape is that these nodes, and actually somebody studied, putting this at an angle, and you can see how there's like density around this, whereas the other areas are less dense. And this is the idea. And there's a paper on it about how the edge effect works on the electric field. Also, this shape of these nodes is being studied in a lattice model, ironically at Emory University, for superconductivity, because the material that they're analyzing, the molecular structure allows for like kind of a sliding of the magnetic field across, the electrical current across, so it's like becomes like a superconductor at lower temperatures. So one thing that occurred to me is that in doing my idea and sort of exploring it, is that I was always like sort of trying to get, I tried this like 2-to-1 ratio in magnet size, but what occurred is that I thought, well, you need to have sort of a more of a ability to have multiple ratios between the field and the rotating armatures, the satellite armatures. So I built this prototype with an engineering researcher, and it utilizes a different architecture, but the same sort of results occur. And this is magnetic viewing film where you can see these projected field lines, and this is the points of attraction, and it allows for basically step gears that are magnetically coupled. And I'm currently have a patent pending on this whole idea. And here's when I received my funding, I've been using part of it to develop more prototypes and part of it to do animations to describe my ideas. And here's a video animation still of this concept of having a big gear coupled to smaller gears. And what's interesting is this doesn't need to occur with planar-concave magnets, but the planar-concave shape does allow for a denser and thicker edge effect because there's more material at these edges. And here's it possibly being used as a water turbine. So getting back to the unrealistic world of trying to actually get funding as an individual inventor, phantasmagorical ideas, if you think about the possibilities of spinning magnetically coupled systems, you can develop a gyroscopic effect, and without touching, no contact rotation, you could sort of hypothetically or theoretically think of really, really high speeds that would, potentially create new types of transportation and travel. Thank you very much for watching my videos, and you can look through YouTube and find some others that describe a little bit better some of my ideas. Good night.